Okay, let's get right into it. These large language models, things like GPT-4, are incredibly powerful, right? They can do some truly amazing things.
Oh, absolutely. The capabilities are just mind-blowing sometimes.
But wow, does that power come with a price tag? We're talking about estimated costs around $700,000 per day just to keep something like ChatGPT running.
Yeah, it's staggering. And think about smaller users.
Exactly. For a small business thinking about using GPT-4 for, say, customer service, you could be looking at something like $21,000 a month.
That kind of expense just puts these, cutting-edge tools way out of reach for so many people, so many companies.
And that's not even mentioning the environmental side, the sheer energy needed for all these massive computations.
Right. But what's fascinating here is that it's not just one or two of these powerful models out there anymore. It's a whole landscape of LLMs.
A whole marketplace, really.
Exactly. Each with different strengths, weaknesses, and crucially, very different costs. I mean, to give you a really stark comparison, processing 10 million of these language units, they call them tokens. Think of them like words or parts of words.
Building blocks.
The building blocks, yeah. It costs about $30 with GPT-4. Now, if you look at a model like GPT-J, processing that same amount, it's maybe $0, 20 cents.
20 cents versus $30? That's huge.
It's a difference of 2 orders of magnitude. And this huge gap, well, it's a challenge figuring out what to use, but it's also a massive opportunity.
An opportunity to be much smarter about how we use these things.
Precisely.
And that's the core of what we're digging into today. We've got our hands on some really interesting research. It's called FrugalGPT, How to Use Large Language Models While Reducing Cost and Improving Performance.
Sounds promising.
Yeah. Our mission here is to pull out the key strategies from this work that can help all of us use these incredible LLMs more affordably, more efficiently, without sacrificing the quality of what we get back.
So getting top-tier AI results without breaking the bank, essentially.
Right.
Or straining the planet's resources.
Exactly. Finding those clever ways.
And this raises a really important point. How do we actually do that? How do we achieve this sort of cost-conscious approach?
Right.
The researchers behind FrugalGPT, they've identified 3 main strategies, and we're going to explore each of them.
Okay, what are they?
They are prompt adaptation, LLM approximation, and the central focus of their research, something called LLM cascade.
Prompt adaptation, LLM approximation, LLM cascade. Got it.
Each offers a different angle on making these models more accessible.
So let's jump right into the first one then. Prompt adaptation. Now, the basic idea here seems pretty straightforward. Since the cost of using an LLM often goes up with the length of your request, the prompt making those prompts shorter, more effective, that's a direct way to save money.
That's right. It's like being really concise, really clear when you ask for something. Saves time, saves effort, saves cost.
Makes sense.
And within this idea of prompt adaptation, the paper highlights a couple of specific techniques. One is called prompt selection.
Prompt selection. So choosing your prompts carefully.
Exactly. Instead of overwhelming the LLM with tons of examples in your prompt to show what you want.
Which costs more tokens.
Right. The idea is to carefully pick just a few, but really effective examples. The trick, of course, is figuring out which examples are the most impactful.
Yeah. Which ones give the LLM the right guidance without just adding length and cost? It's like choosing the key spaces for a dish instead of just dumping the whole rack in.
Perfect analogy. And then there's another technique they mentioned called query concatenation.
Query concatenation. Okay, tell us a bit more about how that works.
Certainly. Imagine you have, say, a few different questions you want to ask an LLM.
Okay.
Usually you'd send each question in its own separate prompt. And you might end up repeating some of the initial instructions or background info each time.
Right, which is inefficient.
Very. So query concatenation aims to cut down on this repetition. The core idea is you combine several different questions into a single, well-structured prompt. You design the prompt so it tells the LLM, okay, answer question 1, then answer question 2, all in one go.
So maybe you give an example Q&A pair for the first, and then another Q&A pair for the second, all in the same input.
Exactly like that. This way, you're getting more done with a single instance of the LLM processing your request. It's like sending one organized email with multiple points instead of, 5 separate emails.
Okay, that's a clever way to boost efficiency. Now, let's move on to the second strategy, LLM approximation. The name itself suggests we're trying to get similar results to the really powerful models.
But using something less expensive, yeah.
Right.
The core idea here is to find cheaper ways to get results that are close to what the high-powered, high-cost LLMs can do, at least for certain tasks.
So how do you approximate?
The paper discusses a couple of main approaches. One involves using something called a completion cache.
A completion cache. That sounds a bit like a shortcut for the LLM, maybe. Like remembering things it's already done.
That's a good way to think about it. Imagine every time you ask an LLM a question and get an answer, you store that question-answer pair.
In a database or something.
Sort of, yeah, in a kind of digital memory bank. Then, the next time you or someone else asks a very similar question, the system first checks its cache.
Checks if it's seen that one before.
Exactly. If it has, it can just pull the stored answer from the cache instead of having to go back to the expensive LLM and compute it all over again.
Ah, I see. That could save a lot, especially for common queries.
Definitely. Think about a search engine using an LLM. Lots of people might search for similar things. The cache helps provide answers quickly and cheaply for those repeats.
So if I ask, what's the capital of France, and get Paris, and then someone else asks France capital, the cache might just serve up Paris again without bothering the big model.
Precisely. Saving compute time and money.
That makes a lot of sense, especially for those really common questions. What's the other main way to do this LLM approximation?
The other key technique is model fine-tuning. Now, this is a bit more involved, but it can be really effective.
Fine-tuning a smaller model.
That's the idea. The process generally has 3 steps. First, you gather a bunch of high-quality answers from a really good, probably expensive LLM for a specific task you care about.
Okay, so you use the expensive model to create training data.
Correct. Second, you use these collected answers to train a smaller, more affordable AI model. You're essentially teaching the smaller model to mimic the quality of the answers from the big one, but just for that specific task.
Right, within its own capabilities.
Exactly. And finally, once it's fine-tuned, you use this cheaper, specialized model for new, similar questions.
And are there other benefits?
Yes. An added bonus is that these fine-tuned models often don't need those long prompts with lots of examples we talked about earlier.
Oh, right, because it's already specialized.
Precisely, which can save even more money and often makes the responses faster, lower latency.
It's like having a master chef teach an apprentice their best recipe. The apprentice might not be a master chef, but they can now make that one dish really well and efficiently.
That's a great analogy.
Okay, fantastic. Now let's dive into the third strategy. And this seems to be a major focus of this FrugalGPT research. LLM cascade. That sounds really interesting, like a waterfall or a tiered system.
That's exactly what it is, a tiered system.
Mm-hmm.
The LLM cascade strategy takes advantage of the fact that we have this wide variety of LLMs available now.
Marketplace we mentioned.
Right, each with different performance levels and different costs.
Yeah.
The core idea is simple. You ask a sequence of LLMs, starting with the cheapest ones first.
Okay.
And you only move on to the more expensive ones if you're not confident in the answers you get from the cheaper models.
Ah, like escalating the issue. It's like having a first line of less expensive support, and you only bring in the senior, more costly expert if the first line can't solve it reliably enough.
Precisely. It's about balancing cost and reliability.
That sounds like a really smart way to handle it. What are the key things that make this cascade approach actually work? What pieces do you need?
There are 2 main components that are essential. The first is what the paper calls a generation scoring function.
A scoring function. What does that do?
Think of it as a built-in quality checker for the LLM's answers. It looks at the question you asked and the answer the LLM gave, and it outputs a score, usually between 0 and 1.
And that score tells you?
It tells you how confident you should be in that answer's correctness or quality. The paper even mentions this scoring can be done by another smaller AI model trained specifically to judge the answers.
Okay, so step 1. Judge the quality of the answer from the current, cheaper LLM. What's the second key part?
The second key part is the LLM router. This is the mechanism that decides, okay, based on that score, what do we do next?
So it directs the traffic.
Exactly. It manages the flow of the cascade. If the score from the quality checker is high enough, above some threshold you set,
You accept the answer and stop.
you accept the answer, stop the cascade, and save money. But if the score is too low,
You route the query to the next LLM in line.
precisely, you move on and as the next, usually more expensive, LLM in the predefined sequence.
So FrugalGPT, the specific system they built in the paper, How does it actually use this LLM cascade idea? Does it just have one fixed order of models?
Good question. No, FrugalGPT is smarter than that. It doesn't just have one fixed sequence it always follows. Instead, it actually learns which combinations of LLMs work best for different types of questions.
It learns how.
It looks at data. For some kinds of queries, it might find that a cheap LLM is almost always good enough. For others, it might learn, okay, for this type of question, I probably need to go to a mid-tier or even the expensive model pretty quickly.
So it figures out the best sequence and those quality score thresholds for when to switch.
Exactly. This learning process involves analyzing past performance to figure out which LLMs do well on what and what scores from that quality checker should trigger moving up the cascade.
And what kind of results did they see? Were the cost savings, the performance improvements, were they significant with FrugalGPT?
The results were really quite remarkable.
Yeah.
Pretty stunning, actually. The paper shows that FrugalGPT could match the performance of the best individual LLM, like GPT-4.
Match GPT-4 performance.
While slashing costs by up to 98%. A 98% reduction.
Wow. That's almost free compared to using GPT-4 directly.
Practically. Or, alternatively, they showed it could even boost the accuracy compared to GPT-4 by up to 4%, while keeping the costs the same as GPT-4.
So better and cheaper in some cases, or same quality and drastically cheaper.
Exactly. And these weren't just theoretical calculations. They tested this using real-world LLM APIs, GPT-3, ChatGPT, GPT-4.
That 98% cost reduction, I mean, that's game-changing, isn't it? What kind of real-world impact could savings like that have?
It could open the door for so many more use cases, especially for smaller companies or researchers who just couldn't afford continuous GPT-4 use before. They could get near GPT-4 level intelligence for tasks they previously couldn't touch.
Wow. Okay. A 98% cost reduction while keeping the same performance as GPT-4. That's huge. Do they have a specific example in the paper that really shows how this works in action?
Yes, they do. They provide a really interesting case study using something called the headlines dataset.
Headlines. What's that?
It's all about financial news headlines. And the task is to predict whether the price of gold will go up or down based on the headline text.
Okay, a prediction task.
Yeah. And they set a budget for FrugalGPT at just 1/5 of what it would cost to use only GPT-4 for this task. So like $6.50 versus $33.10, relatively speaking.
Okay, a tight budget. What did FrugalGPT do?
What FrugalGPT learned to do was this. First, ask GPT-J, which is much cheaper. Then check the quality score.
Using that scoring function.
Exactly. If the score for GPT-J's answer was above 0.96, really high confidence, it accepted that answer. Done.
And if not?
If not, it then asked J1L, which is a model sort of in the middle cost-wise. If J1L's score was above 0.37, a lower bar.
Okay.
It accepted that answer. Only if both of these cheaper options fell below their learned confidence thresholds did FrugalGPT finally go and ask the most expensive option, GPT-4.
That's fascinating. So it really is trying the cheaper options first and only escalating to the big gun, the costly one, when it's less confident in those initial answers.
Absolutely. A very pragmatic approach.
Did they see cases where this cascade approach actually did better than just using GPT-4 on its own?
Yes, they did.
Yep.
They give a specific example with the headline, Gold off the lows after dismal U.S. GDP data.
Okay, what happened?
FrugalGPT, following its learned cascade strategy, correctly predicted that the price would go down. But GPT-4, when asked on its own, got it wrong and predicted price up.
Wow. So the cascade, using cheaper models initially, actually outperformed the top-tier model in that case.
Correct. The paper even shows the actual news headline image, which is neat. And overall, when they looked at the entire headlines data set,
The whole thing.
yeah, FrugalGPT achieved 1.5% higher accuracy than GPT-4, while also achieving that remarkable 80% reduction in cost compared to using only GPT-4.
Better accuracy and 80% cheaper. It's almost counterintuitive, isn't it? That sometimes using less powerful tools, but in a smarter sequence, can actually get you better results.
It really does show the power of the strategy. It's not just about saving money, although it does that incredibly well. It can even lead to better outcomes sometimes.
Which makes you wonder, why does combining different LLMs like this work so well? What's the underlying reason?
That gets to a really interesting concept. LLM diversity.
Diversity, like having different perspectives.
Sort of. The key insight is that even the less expensive LLMs, the cheaper ones, can sometimes get the right answer when the really expensive, powerful ones make a mistake.
How interesting. Why?
Well, different models are built differently. They're trained on potentially different slices of data. They have different internal architectures. They just have different strengths and weaknesses.
So they might make different kinds of errors.
Exactly. By combining them intelligently in a cascade, you can leverage their different strengths. You get a chance to catch errors that one model might make because another model in the sequence might get it right. It's like having a team of specialists.
Right. One might catch something that another one misses because they have different training or focus.
Precisely. A team with complementary skills.
The paper mentions something called maximum performance improvement, or MPI. What exactly does that tell us?
MPI, maximum performance improvement. It's a metric they use to quantify this potential benefit of diversity.
Okay.
Specifically, the MPI of, say, LLMA with respect to LMB is the probability or the chance that LLMA will get the right answer given that LLMB got it wrong.
So it measures how often one model can correct the other's mistakes?
Essentially, yes. It tells you the maximum possible gain in performance you could theoretically see by using LLMA to back up LLMB.
And what did they find regarding MPI?
Their analysis showed that for that headlines data set, cheaper models like GPT-C, GPT-J, and J1L could potentially improve GPT-4's performance by up to 6% in some scenarios.
6%. From cheaper models correcting GPT-4.
Yeah, it really highlights the value of not just looking at the single most powerful model, but considering how these supposedly lesser models can contribute.
That's a significant potential benefit, and FrugalGPT, with its cascade, was able to capture some of that potential and turn it into real cost savings while maintaining or even improving performance across different kinds of data, right?
Exactly. Table 3 in the paper really drives this home. They tested on 3 quite different data sets: headlines, finance, overruling legal text,
With documents. Okay.
and CoQA, which is a conversational question answering sort of reading comprehension task.
So diverse tasks.
Very diverse. And across all of them, FrugalGPT showed substantial cost savings while matching the performance of the best single LLM for that task.
Can you give us the numbers?
Sure. For headlines, the savings compared to just using GPT-4 were, as we said, a massive 98.3%.
It's incredible.
For overruling, also compared to GPT-4, the savings were 73.3%. Still huge.
Very significant.
And for CoQA, where GPT-3 was the best single model, FrugalGPT matched its performance with 59.2% cost savings compared to just using GPT-3.
So consistently saving well over half the cost, sometimes close to all of it, while keeping performance high.
That's the key takeaway. It really shows how FrugalGPT smartly uses the more affordable LLMs for the easier lifts, the easier questions, and reserves the heavy hitters, the costly ones, only for when they're truly needed.
Thinking about practical application again, if you're a small startup looking to integrate some AI, which of these strategies we discussed, prompt adaptation, approximation, or cascade, might be the most accessible starting point?
That's a good question. Prompt adaptation, just being more concise, that's probably the easiest win initially. Looking at approximation, like fine-tuning, requires more effort but could pay off. The FrugalGPT cascade is powerful but needs that setup and learning phase. Maybe starting by exploring if cheaper models alone are good enough for some tasks is a good first step before building a full cascade.
Good point. Start simple. Now, the paper also talks about performance and cost trade-offs shown in their figure 5.
Right.
What does that illustrate for us?
Right, figure 5. It basically gives us a visual map of the options FrugalGPT provides. It shows that it's not just one fixed outcome.
It's a spectrum.
Exactly. It lets users, fine-tune the balance. How much accuracy do you actually need? How much you're willing to spend? You can adjust the thresholds in the cascade.
So you could choose to save the absolute maximum amount of money, maybe accepting a tiny dip in accuracy.
Or you could aim for the highest possible accuracy, perhaps spending a bit more than the absolute minimum, but still likely much less than using the top model alone.
And the really impressive part is?
The really impressive part, shown in that figure, is that in many situations, FrugalGPT can actually lower costs and improve accuracy simultaneously.
Doing both at once.
Yeah, by smartly leveraging the strengths of the different models in the cascade. It finds that sweet spot.
Can you give us a couple of specific examples from that figure to help us visualize these trade-offs in practice?
Certainly. On the overruling data set, the legal one, FrugalGPT managed a 1% improvement in accuracy compared to just GPT-4, while also cutting the cost by 73%.
Better and 73% cheaper. Wow.
And they give an example. GPT-4 incorrectly said no overruling was mentioned in a legal statement. FrugalGPT first asked GPT-J, which correctly said yes, And FrugalGPT's quality score was high enough to accept that correct answer.
So the cascade caught GPT-4's error using a cheaper model?
Exactly. Then on the headlines data set, there's another example. GPTJ's first answer was scored as unreliable. So FrugalGPT moved on to J1L, the mid-tier one.
Okay.
J1L gave the correct answer, which FrugalGPT accepted. In that same case, GPT-4 actually got the answer wrong. Again, the cascade did better.
It really shows the system working? But it's not perfect, right? You mentioned a limitation.
Right. The researchers are upfront about that. Sometimes, like in one of the co-QA reading comprehension examples they show, all the LLMs in the sequence might give the same wrong answer.
Ah.
In those cases, FrugalGPT, following its rules, still ends up querying all of them sequentially, even though the first answer was wrong and the subsequent ones didn't fix it.
So it incurs the cost of querying multiple models without getting a better result in that specific instance.
Correct. That highlights an area where the strategy could potentially be improved in the future. Maybe better ways to detect when further querying is likely futile.
That's a good point. Even with these sophisticated approaches, there's always room to refine and get smarter. The paper also briefly mentioned something about how the relative cost of different LLMs isn't fixed.
Yes, that's a really important practical detail. The paper points out that which LLM is considered cheaper or more expensive can actually change depending on the specific task and the data you're using.
How so?
Well, for instance, maybe Model J1 is more expensive than GPT-3 for analyzing short financial headlines, but it might be cheaper than GPT-3 for generating long answers to comprehension questions.
Why would that happen?
It's mainly down to how the different providers structure their pricing. Some charge more based on the number of input tokens. Others charge more based on the output tokens generated. Some might have fixed costs per API call. It varies.
So the optimal cascade sequence might even change depending on the typical input and output lengths for a given task.
It absolutely could. And this variability really underscores why a flexible, adaptive strategy like FrugalGPT, which learns the buffed approach based on the specific context, is so valuable. It can take these shifting cost dynamics into account.
Okay. So to bring it all together then, what's the main thing we should really take away from this deep dive into FrugalGPT and these strategies for making LLMs more affordable?
I think the big picture is that there are really significant, really exciting opportunities now to use these incredibly powerful large language models in a way that's much more sustainable and, frankly, affordable.
We don't have to be locked into just using the most expensive one all the time.
Exactly. By being smart about which models we use, when we use them, and employing clever techniques for crafting our prompts and maybe using caching or fine-tuning, we don't have to be limited by those headline-grabbing high costs of the absolute top-tier models for every single query.
And the three main ways we can approach this, as we've discussed, are prompt adaptation, just making our requests leaner and meaner.
Right, efficiency in the ask.
LLM approximation, finding cheaper ways like caching or fine-tuning to get similar results.
Getting good enough for less.
And the focus of the FrugalGPT research, the LLM cascade, strategically using that sequence of models, starting cheap based on cost and reliability.
Precisely. Those are the key strategic levers.
And while FrugalGPT shows a lot of promise with this cascade approach, it's important to remember the limitations too, right?
Absolutely. The researchers are clear about that. FrugalGPT, in its current form, needs labeled data to train the scoring function and the router, which means there's an upfront effort and potential cost there.
So it's not completely free to set up.
No. And they also rightly note that their main focus in this particular research was primarily on optimizing for performance and financial cost.
Which naturally opens up some interesting directions for future work, doesn't it? What else could be considered?
Oh, definitely. The paper suggests several important areas to look into next. Things like considering other crucial factors beyond just accuracy in dollars.
Like what?
Like how fast the LLMs respond. Latency is critical for many real-time applications. Also, fairness in the outputs, privacy considerations, especially with sensitive data.
Yeah, those are huge.
The environmental impact, measuring the energy consumption of different strategies. Better ways to quantify how confident or uncertain the models really are in their answers.
Uncertainty quantification, yeah.
And of course, just keeping up. The LLM landscape is evolving so rapidly, with new models and new pricing structures appearing all the time. These strategies need to adapt too.
It's a fast-moving field. So here's a final thought for you, our listener, to maybe chew on. As the capabilities of these large language models continue to grow at this incredible pace, How will these kinds of cost-saving strategies we've talked about, like FrugalGPT's Cascade, ultimately shape who gets to use them? And how deeply will they be integrated into our everyday applications and lives?
That's a great question. Will it democratize access?
And what new, maybe even more creative hybrid approaches might emerge? Ways of combining the strengths of different LLMs, maybe with even smarter optimization techniques that lead to a future where the amazing benefits of these AI tools are more widely available, more accessible, and used in a truly sustainable way.
Definitely something to keep an eye on, and perhaps even experiment with yourself if you're working with these models.
Absolutely, lots to think about there.